So I'll go to next chapter. Okay, next chapter is what is device and behavior in DIATwin. Like you already know how to create style interface, right? And style interface is a kind of behavior. So what is behavior in DIATwin? You can also find it in our list. Okay, like container, we got some frame reference for controlling the component behavior. Like we have to make sure what is the relationship between IO control and the track or the air cylinder. There's a lot of built-in behavior really help you to build it out. So in DIATwin, you don't need to write. Okay, I mean you don't need to implement what is the component behaviors because we already have a lot of built-in behavior for you to use. Okay, you can see a lot of LED, vacuum gripper, camera, and also like some robotics function already ready for you to use. And another is devices. Okay, devices means we just need to point out what feature or what point you want it to have the device of it. Okay, like here. Basic feature, the basic function that you need to edit in Twin. Like here, if I need this space have a track behavior, you just select track. A track device. If you need to have a track device, you actually just select track. Okay, and then point out the direction and the orientation, and then press apply. Okay, only the device will create the structure right here. Okay, it will be a track device. Okay, so if you also like want a camera right here, okay, maybe at this tool, okay, I need to have a camera device. Okay, I just press device and press camera. And then you can just like select, maybe you can just imagine the camera. You can select the point. And this will be the camera point right here. And then press apply. Okay, so you can see here will be a camera device right here. Okay, you can see, but I think the main difference, you will not know what is the difference between devices and behavior. So now I will tell you. Okay. So like here, if you already have the camera, but you can see now we don't have any IOs or another way to control this camera. Like if you want to control the shutter of it, I don't know how to control it, right? So now we'll use another way is we use the behaviors. Okay. So in behaviors, we can find here's also a camera. Okay, camera. So under this camera, okay, sorry, I will just make it make the camera right here. Okay. You can also just organize the layer through placing these devices. Okay. So you can see now in this camera, we already add a camera behavior. Yes. You can see now we already can find a lot of property for you to control this camera. Okay, you can see the camera behavior, we can just select camera. Okay, and right here, you have to control like the input output right here. So when the input will be true, and the camera will take a picture. So the devices only point out the help you to point out the point, and also just make sure that you already know what feature will have the camera behavior, but you will not control it directly. Okay, if you want to make it like able to control with IOs, you have to make sure you also create another corresponding behavior for you. So you can see now I just select camera, okay, and then you can see here's visual input is empty, okay. If I want to control the control of the camera, okay, here's also another one. Okay, you can see here's the IOs. IOs right here. So if I want to control the camera, maybe I have to receive some signal from the controller. So I'll just create a receiver and then press apply. So you can see now in this behavior, here will be a receiver for you to select. Okay, so that is between the relationship between device and behaviors. Okay, I'll just maybe you can just follow up with the slide first. So we just doing the action. You just add a friend for device, okay, and then you just point out what is the action you want to do for simulation. Okay, like if you want to do action like dispensing, maybe it will be pen device. If you want to do action like position detection, maybe there will be a distance sensor. Okay, if you want to have a illumination, maybe there will be a spotlight, okay, like this. Okay. Also, maybe we'll have a spotlight device for you. But now you can see all these devices will not have control. Okay, so if you need control, you have to create a corresponding behavior. Okay, I see here also have some explanation for this icon and the device name. But for tomorrow's modeling lecture, I will just we can do it one by one. So you can note that there will be a lot of devices in DIATwin for electrical components behavior already. Okay. Okay, here also some camera, distance sensor, touch sensor, all of these common electronical components is already built in DIATwin. Okay, and you have to remember these two one. Okay, these two one will be used very common. Okay, one is emitter, means the digital output of this component, and another is receiver. Okay, like if you want to receive the signal from another component, maybe you have to create a receiver. Okay, that's for this example. Okay, if you want to receive a signal, yeah. Smart screw. Okay. Okay, like if you want to have a smart screw, you can see now there's no smart screw behavior in Twig right now. So if you want to just have a like a smart like a screw like example, maybe you can just see right here. Okay, we also already got an example, but actually we don't have a smart screw, Delta smart screw right now, but you can build up with the combination with behavior and device by yourself. Okay, so like here, you can see here the screw, okay, screw machine. And this is also in our model library. Also, we can maybe take some time to build up what is using for smart screw, okay? Like here's a screw module, okay? The screw tool is right here. But you can see now we have the camera. Okay, camera is right here. Okay, you can see now we point out the camera device and the endpoint of this. The endpoint of this camera feature will point out the camera. Okay. But also, if you want to have a vacuum gripper for this, a vacuum way to pick up the screw, maybe here will be a connector. Okay. The connector will just help you to pick up the screw right here, and then fix the tool on the tool head. Okay. So like here, but you can see now there's no control of it. So you can see if you want to control camera, need to control the connector. You can see here we got the here we got the camera behavior right here. Okay, and you can see here will be a R03 control. This one will be the receiver. Okay, receive signal and control the camera. Okay, and here also like here we got the vacuum. Okay, vacuum here will be control the connector one, and it will be controlled by R01 gripper, and this is the behaviors. Okay, can see behavior. Okay, we'll create camera, we'll create vacuum gripper to control the corresponding camera, control the corresponding connector. So actually, we don't have built-in delta screw, delta screwing module, okay, but we can have this kind of behavior. Okay, at least also can help you to have a live behavior in DIATwin right now. And here, and also it will rotate. Okay, please. So okay, so I'll go on. Okay, so next is behavior. I think I really help you to explain it. Okay, first you can just select some component, configure the component attribute like IO signal, okay, like a star interface, okay, and it will be in modeling in the component tree. Okay, it's right here, modeling. Okay, here will be behavior. Okay, and also you can just right click on it, and here is also behavior for you to select, and also here, okay, right click. They also select the behavior. Okay, so here's some typical way. What is the behavior need to be selected in the whole layout? Like if I want to have a top controller, mostly we'll have to use executor, but for a PLC. And the servo controller is also need to use like to control some ASICs right here. And like for robot arm, we also have the top controller for it. So we also need the executor. Okay, so executor means the top controller, okay? But for servo controller, maybe there will be some ASICs or not, it's also fine. Okay, so like if you want to control the Delta robot, we also already have an articulated controller. Okay, here's an example. If you want to control the Delta robot, okay, I just double click on this robot. Okay, you can see here's also like a Delta SCARA controller already. Okay, but we don't have screw module right now. Okay, but we already have the built-in Delta SCARA controller. Okay, so maybe I'll just go back to the project to see what behavior is already built in our example. So let's go back to this training model. And I think at tomorrow's lecture, we'll do it one by one. So it will be more easy for you to memorize what situation you have to use what behavior and what devices. Okay, like here, okay, for the robot, okay, robot mostly we will not create devices because robot don't have any component, electronic component behavior. Okay, we know also we only need to control the assets at least. Okay, so later, tomorrow I'll teach you how to control the assets. You can see here's only some assets. But here we'll have some emitters of the robot, receiver of the robot, such as which is representing the digital input and output. Okay, and now you can see like if you want to model a robot, you have to select the executor. Okay, and the executor means the top controller, and the controller right here, right now will have the controller behavior, and then right here we'll select the joint. Okay, maybe here is another example, like using a tool. Okay, we got behavior for the sign interface. But you can see here's another behavior, is vacuum gripper behavior. Okay, vacuum gripper behavior will ask you to control the connector device and also a receiver for you to control the connector. Okay, the structure for modeling is designed in DIATwin like this way. Okay, so here you can see vacuum gripper, we got vacuum gripper behavior. Conveyor, we got conveyor behavior, and also we need to create the track device. Okay. like if you want to control cylinder, maybe it will be a cylinder behavior. Okay, sensor will be after the sensor behavior. And there will be a lot of corresponding device you have to build it first. Okay. Like here, okay, maybe here's a sensor. Okay, the sensor we have optical sensor behavior. But you can see in this behavior, we have to control the descent sensor and the digital output. Like if you're sensing something, maybe you have to export some signal to our top controller. So you have to build it, the optical sensor behavior like this way. So you can see here's the descent sensor one. Okay. So first descent sensor one, maybe you can just find it out. Like maybe here, okay. Here will be a descent sensor one. You can see here's the origin of it. Here's the direction of it. So you can see now we just make sure this descent sensor will be right here to detecting something. And if you want this descent sensor to export the signal by using like DS1. Okay, so you have to create the after sensor behavior. You can see the descent sensor after sending something, and it will export true signal to DS1 like this. Okay, but now we already have some concept like DIATwin's behavior can help you to communicate the electronical signal, okay, as using to like our emitter and receiver. But now we have another way. Another thing is we have to create the I/O mapping table for you to make sure that like each component there have the I/O signal to control it. Like PLC have to send a control digital output. It will be an emitter to this conveyor. And at the conveyor side, you have to create a receiver to receive the signal from the PLC. So here will be an emitter and a receiver, and you will be create a link right here. So that it will make you able to control the PLC to the conveyor. Okay, so like here's the structure. If I want to have here's the top controller. Okay, here's a robot. The robot has an emitter to send the true signal to the receiver of this gripper. So the gripper will know now you have to grip something. Okay, and now maybe the gripper is arrived the signal, arrived at position, and or maybe we just like return a successful signal back to our robot. So now there will be a emitter signal at the gripper, and also we have to create another corresponding receiver right here. So that will be like a communication between these two components. Okay, here's another more complex. Okay, you can see like robot will control the behavior for generating the material. Okay, robot will control the conveyor of start and stop conveyor. Okay, and maybe here's also a signal for a sensor. You have to return and send to the robot. Okay, maybe there will be a control for control the gripper. Everything will be controlled by using I/O signal handling. Okay, and maybe we'll just try an example by using this project. Okay. So you can see in this project, okay, in how can we configure the I/O table in our DIATwin? Okay, you go to program. In program sheet, here will be a signal icon right here. Okay, and then you can just click on everything. So you can see here's a lot of wire already being created. Okay. So like maybe we can just focus on one thing. Like if I delete the robot signal, okay, I can just press right click and delete. Okay. And E1, EO1 and EO2. Okay, EO1 means control the robot the robot will send the signal to the master controller. Okay, and the left-hand side, it means the output. Okay, and the right-hand side means the input. So robot will send the output to the controller, and so the controller will receive a signal. Maybe like this one is like a process down signal. Okay, and then maybe for 1 or 2, you will have to control the robot tool. Okay, for controlling the vacuum cleaner signal like this. Okay, so like here, if I forgot to wire up the 102 E02 signal for vacuum cleaner, you can see here's the vacuum cleaner and the robot tool. So when we start simulating, there will be no control for the vacuum cleaner. So you can see now it will not pick and place the top cover. But if I wire in the signal back, now it means the robot will send a signal to the robot tool. Okay, so now you can see when we just start the simulation, it will help you to pick up the component right here, okay, like this. Okay, and also in our layout here, so also another signal right here for you to press. Okay, so like here you can just go to layout. Also here's another button, signal. Okay, so you can also open up with this pop-up window. Like if you want to like another signal to control something, okay, you can just use drag using a right click, select, and here will be a line for you and ask you what component you want to wire up. Okay, maybe like this. And here will build up a line, and you can right click to delete it. I think we have an example. Okay, maybe you can just help me to import example IO setting.dtl, okay, for you, because this is a complex project. Maybe you can start with a single project. Okay, so we'll go to file. Okay, new file. Okay, so please help me to open the project. In our today's training model directory, and here's the EX setting.dtl. So open it. Okay, now we already help you to build up every IOs and every component, but we did not help you to implement the IO signal. So you can see when we just start the IO settings, there will be nothing. Okay, so you can go to program or go to layout. It's also fine. Just find out the signal control icon right here. Okay, and please help me to wire up. Okay, like first thing. Okay, from the full process. Okay, now we have to generate the product in the front hand side of this conveyor. So you can see now the component will be the robot. Okay, so the robot will like source. Okay, create the object and create a tray. So maybe you can just select tray to find out where the tray. Okay, here's the tray. Okay, see tray to tray, source tray. Okay, and maybe the robot will also need to create a product right here. So you have to find out source. Okay, source object right here. Okay, maybe after in the next, maybe you have to start conveying something. So you can see the robot also will control the track. Okay, so the track will also control the conveyor. So also the conveyor will have a receiving the signal from the robot will control the track. So track to track. Okay, and then maybe for the gripper right here, you can see here's also the output from the robot and also the input right here. So catch to catch. And finally, maybe when the tray arrives to this position, and here will be a sensor. So the sensor will output the signal, okay, return signal of the sensor to the robot. So you can see now the sensor and the robot is right here. So after everything is wiring up, now you can start simulation. You can see now the generator of these two source signal is work properly. Okay, and then it just the sensor return signal, okay, and also the vacuum clipper already have the signal to pick the object. Okay, so everything goes well. Okay, so please help me. So now we'll take a practice. Okay, it's quite easy. Okay, just go to the project. You can find EXIO settings, import it, and then you go to signal. Okay, you can see now there's already disconnect. Oh, okay, you can just find the same name and just connect to each other, like sensor, track to track, tray to tray, source to source, and catch to catch. So we already renamed the emitter and receiver name, okay, to each electronical component behavior. So you already know what link need to be connected to what link. So after it's do it properly, so now when you just start simulation, I think it is already have a project that is able for you to pick something and place it on the tray and finish the process, and then you can see the result and will just convey out at the end of the conveyor. Okay, let's take a try.